Hello everyone. I welcome you all once again. I am Chetan Rajoria from ABES Engineering College, Ghaziabad, and I am going to cover up the unit number 1 of the subject Fundamentals of Mechanical Engineering. The subject code is BME 101 or BME 201. So this is basically the fourth lecture of the series, and in this lecture I am going to take up a numerical problem based on the resultant of a concurrent force system. So let's start. So students, this is the problem. The forces of 2 kilonewton under root 3 kilonewton, 5 kilonewton, under root 3 kilonewton, and 2 kilonewton, respectively, act at one of the corners of a regular hexagon towards 5 other angular points. So basically, there are 5 forces. All these 5 forces are concurrent in nature, and these are directed towards the 5 angular points of a regular hexagon from one single point towards the 5 remaining other points of a regular hexagon. So let's start. Let us draw an approximate diagram for this question. So this is the first force of 2 kilonewton. First of all, let's create a hexagon, a regular hexagon. So this is a regular hexagon, and the first force is acted from point A towards B. This point is C, D, E, F. So the second force of under root 3 kilonewton is acted towards point C. It is having the magnitude of under root 3 kilonewton. Next force of 5 kilonewton is acted towards the point D. Along the major diagonal, the magnitude is 5 kilonewton. Next one, under root 3 kilonewton once again. And the last one, 2 kilonewton. In this question, it has not been mentioned that what is the orientation of the hexagonal shape. So we can choose any random shape, hexagonal shape, and I have chosen in such a way that the major diagonal is in the horizontal position. You can take some other position also. Accordingly, the magnitude will be same, resultant magnitude will be same, but the direction of the resultant will be different. So the direction of the resultant will be as per our initial assumptions. In what way we are assuming the initial orientation of this hexagon. Sometimes the orientation of this hexagon may also be given in the question. But right now, there is no as such any information available that what kind of orientation of this hexagon we need to take up. So I have assumed this type of orientation, okay, in which the major diagonal AD is horizontally kept. So accordingly, my answer will be as per this orientation only, fine? But the magnitude will be same in each and every orientation, whatever we choose. So these are the 5 forces. All these 5 forces are concurrent. As we can see here at point A, the 5 forces are concurrent in nature. How to find the resultant? For finding the resultant, we will first of all calculate the summation of all the forces along x-axis, then summation of forces along y-axis. Then we will use the formula of resultant is equal to under root of summation of forces along x-axis whole square plus summation of the forces along y-axis square. So let's start summation of forces along x-axis. But prior to that, we need to define each and every angle of these forces. Now, because this is a regular hexagon, we know that the major diagonal bisects the total angle. This complete angle is 120 degrees. Therefore, this half angle will be 60 degrees. Next one. Now look at this triangle AEF. In the triangle AEF, this angle is 120 degree. And AF is equal to FE. Therefore, angle FAE should be equal to angle AEF. If this angle is 120, so the remaining two angles, the summation of these two angles must be equal to 180 minus 120, that is 60 degrees. Therefore, this angle should be 30 degree. And this angle is also 30 degree. Okay. So this is 30, this is 60. Means this angle is 30 degree. 60 minus 30. Similarly, we can conclude that this angle is also 30 degree and this angle will also be equal to 30 degree. So all these five forces are dividing the whole angle of 120 degree into four equal parts, 30 degrees each. So summation of forces along x-axis, that can be written as 2 kilonewton, and its horizontal component will be towards the right hand side. We will take it as positive. So it can be written as 2 cos 60 degree, because the angle of this 2 kilonewton force is 30 plus 30, that is 60 degree with horizontal, if we are assuming that this is the x-axis and this one is the y-axis. So 2 cos 60 plus under root 3 cos 30 plus this is the complete force along the x-axis 5. So you can write 5 cos 0, or simply you can write 5 plus AE, that is under root 3 cos 30 plus 2 kilonewton cos 60 degree. So we can see that all the horizontal components of these five forces are acting towards right hand side. Therefore, all these components are positive. Fine. So if we calculate these values, it is found to be 10 kilonewton. Now let's calculate summation of forces along y-axis. Summation of forces along y-axis, we will choose these five forces one by one. Let's take 2 kilonewton first. So the vertical component of this force will be in the upward direction. It will be considered as positive. Vertical component of under root 3 kilonewton will also be in the vertically upward direction. It will be considered as positive once again. There will be no vertical component of this horizontal force, 5 kilonewton. It's purely horizontal, so there is no vertical component. The vertical component of this force, under root 3 kilonewton, will be in the downward direction, so it will be considered as negative. And the vertical component of this force, 2 kilonewton, will also act in the downward direction, so it will be considered as negative once again. So let's write 2 sine 60 plus under root 3 sine 30 plus 0, because there is no vertical component of this horizontal force. Okay, AD minus under root 3 cos 30 minus 2. Just a minute. It should not be cos, it should be sine. Under root 3 sine 30 minus 2 sine 60. So we can see that the first and the last one are cancelling out each other, and the second and the fourth is also cancelling out. So summation of forces along y-axis is actually 0. So how can we calculate the resultant? The resultant will be equal to under root summation of forces along y-axis square plus summation of forces along x-axis square is equal to 0 plus 10 square, that is 10 kilonewton. So the resultant of these five forces is equal to 10 kilonewton. And how to calculate the inclination of the resultant? For finding the inclination, we will use this formula. Tan inverse summation of forces along y-axis upon summation of forces along x-axis. So this is the formula to calculate the angle of the resultant. Let's put the value tan inverse. What is the value of sigma y? It's 0 upon 10. So tan inverse 0 upon 10, that is tan inverse 0. So the value will be 0 degree. So the resultant will go in this direction. That is, the resultant will go in this horizontal direction like this. This is the direction of the resultant. Magnitude is 10 kilonewton and the angle is 0 degree. So in this way, the problem has been solved. Okay. Thank you so much, students. See you in the next lecture.